All right, finishing up chapter 1 with section 1.7, absolute values. So in the introduction video here, we're just going to talk real quickly about what absolute value means and how to think of it. So if I say that x, the absolute value of x, that's what these two vertical bars mean. It's just a symbol that was decided to be used. If I say the absolute value of x is equal to 6, that just means that whatever is in here inside the absolute value is equal to 6, or the size of this number is equal to 6. And what that means is x could be 6, or x could be negative 6. Absolute value, you could think of it as like the distance from 0. Okay, whether x is 6 or negative 6, it is 6 away from 0. Its absolute value, its size, is 6. So there you go. There's an example of just what the absolute value means. So it just basically means whatever's in here, it's positive. So the absolute value of negative 3, how far is 3 away from 0? Yeah, it's 3 away from 0. The absolute value of positive 5 is positive 5. The absolute value of negative x is x. Okay, so there you go. Now if I were to say that the absolute value of x is less than 5, what does that mean? Well, we want a number in here that when you take its absolute value or you make it positive, it's less than 5. Okay, so if x were less than 5, we take the absolute value away, that looks like it would work, but we want the absolute value of x to be less than 5. So think about this. What if there was a negative 6 in there? Well, negative 6, the absolute value of negative 6 would be 6, and then that would not be less than 5. So x needs to be less than 5, but it could be negative, and it could go as negative as right up to negative 5, and not including it because there's no equals to. So x could go all the way down to almost negative 5, all the way up to almost positive 5, and anywhere in there, the absolute value of x will be less than 5. No matter what's in there that either is positive or gets made positive, it'll be less than 5. Okay, so what if the absolute value of x is less than or equal to 5? It's pretty much the same thing. X needs to be less than or equal to 5. So it can go all the way up to and including 5, or it can go all the way down to and including negative 5, but no farther than that. How about if the absolute value of x is greater than 3? Well, that's a little bit different. If x could be greater than 3, that's for sure. But you couldn't go back like in the same way that you would here and say, well, we'll go all the way down from 3 to negative 3, because if you went down from said x is 2, well, 2 is not greater than 3. X needs to be, and let's graph it here. This may help. Here's 3, and x needs to stay above positive 3, and it's not equal to, so we put an open circle there. But also just the absolute value needs to be greater than 3, so what if x was like negative 100? The absolute value of negative 100 would be positive 100, and that'd be bigger than 3, so there must be some negative numbers that we're allowed to use, and you probably would be able to figure out, yeah, negative 3, that would be the cutoff. As long as it's not between 3 and negative 3, the absolute value is going to be greater than. If it's negative 4, negative 5, or negative 6, or negative 7, then the absolute value is going to be greater than 3. And then, of course, so this x needs to be greater than 3, or x could be less than negative 3. And if the absolute value of x were greater than or equal to 3, then x could be less than or equal to negative 3, or x could be greater than or equal to 3. Okay, and that graph would look very much like the graph we just made. 3, -3, only with closed circles and shading. Okay. So that's it. That's just the idea of what an absolute value is, what it means, and just a little bit of the concept of, just kind of thinking through what would it mean to write the absolute values of x is less than 5. So also inequalities involving absolute values. All right, thanks for watching.